All right, next thing we're going to do is factoring. Okay, we're going to start out with factoring a trinomial. Okay, so from that name, tri means three terms. All right, so the first thing we're going to do is know your signs. So all trinomials that are factorable, okay, not every single one's factorable, but all the ones that are will factor into two binomials. So we write that in two parentheses like this. We'll have a term here and a term here. We'll have a term here and a term here, and there'll be a sign in between them. Okay, so this page is about knowing your signs, and there's three different types. So first type is your trinomial can have pluses in both spots, plus, plus. Okay, if that's the case, that means that these are also going to have to be both pluses. All right, the reason that is because this last term, if we do FOIL, you're going to have to multiply the last term times the last term. So that's going to be a positive times a positive, which equals a positive. Right there. Okay, but you're also going to have to do the outside term plus the inside term. That's these two and these two. Okay, and for that to add up to a positive number, we need to have a plus a positive number plus a positive number, which is going to be positive, and that's that one. Okay, the second type is very similar to this, except it's a minus in the middle and a plus on the end. Okay, so we still have our two binomials here, except we don't want a plus and a plus because that won't add up to a negative. It's going to add up to a positive, right, because the last one. So we actually want a minus and a minus. And the reason this works is because you have a negative times a negative. Negative times a negative equals a positive number. And that gives us the positive number here, but when we do our FOIL part where we do that and that, we're going to get a negative number plus a negative number, which equals still a negative number. And we wanted that for the middle. Okay, so that's why the negative is important. All right, then our final type over here is when you have a negative on the end. Okay, and I put a plus or minus here because it really doesn't matter whether it's plus or minus. If there's a negative on the end, your signs always have to be one positive and one negative. Okay, and the reason for that is because when we multiply those together as part of FOIL, that's a positive times a negative, which equals a negative. And that's the only way to get a negative when you multiply together. You'll notice over here with the two negatives, they multiply to get a positive. And over here, the two positives multiply together to get a positive. So the only way you could possibly multiply to get a negative on the end is with a 1 plus and 1 minus. Okay? And then you just gotta have to work it out to figure out what they add up to in the middle. All right, so let's try a couple examples. These are the easiest ones. These are trinomials where the leading coefficient is 1. So what that means is that in front here, there's no other number. So it's assumed to be a 1. Okay, now you'll never really see that 1 written there. Okay, but if there's no other number, that's what they're talking about, leading coefficient of 1. All right, these you can just jump straight into the parentheses. Okay, so the first terms, remember FOIL, first terms have to multiply together to equal this first term. So what times what equals b squared? Well, b times b. Okay, remember what we just talked about with the signs. These are both pluses, so these are both going to be pluses. All right, now here's the tricky part. You got to figure out what numbers multiply to equal 7 and add to equal 8. Multiply to 7, add to equal 8. So out to the side over here, if you write down the number 7, okay, write down all the possibilities of things that multiply to equal 7. Okay, well 7 should be an easy one because it's a prime number. There's only one combination, 1 times 7. That's the only ones. Okay, and hopefully those add up to 8, which they do. So b plus 1, b plus 7. Okay, give this one a try on your own. Pause the video, come back, see if you did it right. All right, so this one we've got m plus, and since I have a negative on the end, I know the other one has to be a minus, m minus. All right, let's write down negative 90 and see if we can figure out numbers that multiply to equal 90 and add to equal 1. Okay, so if you start at the top, 1 and 90. Okay, that's not going to work. 2 and 45. 3 and 30. Okay, and you kind of work your way down the list, and eventually you'll get to 9 and 10. Okay, 9 and 10 is going to be able to add up to 1 because one of them has to be a negative. All right, if I want it to equal positive 1, that's going to be negative 9, positive 10. See how those add up to 1? So m plus 10 and m minus 9. All right, next thing I want to talk to you about is GCF. Okay, factoring and greatest common factor go hand in hand. All right, and that's what GCF stands for, greatest common factor. All right, you especially want to use this if you see one like this that only has 2 terms. See how it's not really a trinomial, it's missing that third term. Okay, same thing over here. That doesn't mean it's not factorable though, it just means we have to do it a different way, okay, with GCF. So GCF means you look at the 2 terms and you say, what do these 2 terms have in common with each other? Okay, well what I notice is that both of these numbers are divisible by 8. So we say that they have an 8 in common. Okay, I also notice that both terms have at least one x. Okay, and if you write them out like this, now you don't have to do this every time, but just to give you a good visual. So this is like 8 times 2 times x plus, and then this one's just 8 times x. Okay, and you see that they both have an 8, and they both have one x. Okay, they don't have anything else in common because I'm out of stuff over here. Okay, if there was like another times 2 over here or something, then I would underline those as well. So we do what's called factoring that out. So we're going to take out an 8x. Now it doesn't go away completely, it's still outside the parentheses, all right, but we're taking it out of the original binomial. Okay, and then when you do that, those get divided out. So kind of just think of them like they're canceling like this. All right, but really it's like a division problem. So this is like it's getting divided by 8x like that. Okay, so what's left here? That's 2x. All right, and then what's left here? So everything canceled, but again, it's a division. 8x divided by 8x. So it's not just 0. Remember, if you divide like 8 divided by 8 is 1. So there's always going to be at least a 1 left over when you do this factoring. All right, and that's the factored form there. Okay, so y'all give this one a try. Pause the video again, try it on your own, unpause, see if you got it right. All right, so this one, again, I'm going to draw it out so we can visually see what's going on. 25 is 5 times 5, x times x. Okay, so you see how they have a 5 and an x in common, 5 and an x. So we're going to take out 5x, that'll leave us with 1 minus, and then there's a leftover 5x in there. All right, so next thing, back to trinomials now. Leading coefficient is 1 with a GCF. Okay, so it actually doesn't look like the leading coefficient is 1, right? Because that's a 2 there, and then this one's a 3. Okay, but the with the GCF part is what's important. So now a GCF has to be in common with all 3 terms. All 3. So like what number would all 3 terms be divisible by? Do all 3 terms have a k? Okay, so again, I'm going to draw it out explicitly so we can really see what's going on. And then this one, we have the 2 times 11 times k. All right, I could break this one down a little bit more, but for the sake of time, 2 times 30. All right, so you notice how they all have a 2. 2 and a 2. Okay, but that's really it. There's no more numbers over here, and this one over here doesn't have any k's. So 2 is all we can do. So I'm going to factor out a 2, and then what's left over stays inside the parentheses. So k times k, that's k squared, 11k, and 30. Okay, but we're not done yet. This thing left in the parentheses can be factored. Now we'll see how it has a leading coefficient of 1. So now we can just follow those rules like we did from the first page. So remember FOIL, the first terms multiply together to be k squared, k times k. Okay, it's got plus and plus, which means this is going to be plus and plus. Okay, don't forget about this 2, that is part of your answer, so let's bring that down in front like that. All right, so last thing left to do, what numbers multiply to equal 30 and add to equal 11? Okay, so you write down all the combinations of 30. 1 and 30, that's not it. 2 and 15, 17, it's still not it. 3 and 10, that's 13, not quite. 5 and 6, looks like a winner. 5 plus 6 is 11, and 5 times 6 is 30. All right, give this next one a try. See if you can get it right. Unpause it and see if you did. All right, so this one has a 3 in common. So I'm going to stop writing them out like this every single time. All right, you want to start looking visually so these problems don't have to be so overbearing where you're writing out tons and tons of work. All right, so you just look at it. All 3 of those numbers are divisible by 3. So I'm going to take out a 3. That leaves me with n squared. Remember, when you take something out, it gets divided. 15 divided by 3 is 5n, and 108 divided by 3 is 36. All right, and then we break this down into our 2 binomials. Okay, bring down the 3 in front. We've got n times n. All right, and then we have a negative on the end. So remember, that's what the one where you get a positive and a negative. All right, so I need numbers that multiply to equal negative 36 and add to equal 5. So 1 and 36, that's not going to be it. 2 and 18, still no. 3 and 12, still not quite there. 4 and 9. Oh, looks like we have a winner, right? Because if one of them is a negative, those are going to subtract. 9 minus 4 is 5. So that would be positive 9 minus 4.